Well, hello YouTube. So today I'm going to show you guys how to weld up a 9-inch Ford differential. Step 1, take off your tires. Now pulling the axle on 9 is pretty simple. There's 4 bolts right here on the inside that you can see, hopefully. They're 3/4 inch. You take those out and the whole brake and axle will come off. So let's do that. Okay, so I pulled the axles out, and we only need to pull them out a few inches until they fall out of the carrier. You'll know when that happens, you'll feel it, it'll fall out, and that's all the farther we need to go out. Now, if you want to do differential things, you should just pull it all the way out. Nothing's going to impede you, it'll pull all the way out, no problem, and count the splines, because a lot of 9 inches come with 28 or 31 spline axles. Aftermarket's 35 or 40 typically, but you'll need to know that if you're ordering a spool, a new carrier, a locker, things like that nature. But our next tackle is to go take the drive shaft off. Yeah. Okay, drive shaft is out. Next, we got to pull the pumpkin, third member, this thing, whatever you want to call it. So, one way to tell if it's a 9-inch Ford versus an 8-inch is, if you look under here, these 2 bolts, they're studs underneath the pinion. You can't get on them with a socket. If you can't, it's a 9. If you can, it's an 8-inch. So, these are 9/16. I'm going to zip this off real quick. Okay, so I'm back from dinner. Looks like it drained out pretty well. There's oil in there. That's freaking good. So I had a little more trouble cracking this open than I thought. I used a cold chisel. The guy that had this part before just used some RTV to seal it up. So I'll assume that holds it in there a little better. If it's a regular gasket, it might pop off better, it might not. So there that is. Okay, the next step is to pull the whole carrier out. These are your bearings underneath, right there. Now, one thing I didn't mention, I marked on the carrier and the ring gear, I put a yellow line on them so that I put it in the exact same spot I took it off at. It could, I don't know if it actually would, but just so it goes on the same way it came off. And these, you want to make sure that you keep your left and your right together and that you can't flip them around. Took my bearing caps off, got the ring gears off, the ring gear bolts. I'm going to smack this with a hammer and lightly, and hopefully it'll pop off. Okay, so we need to split the carrier open. I kind of started working on it a little bit. You got to use a cold chisel and you slowly drive this top piece out, and then we can get to our spider gears, which is the reason we came here in the first place. So this here is the splines for the axle. So your axle, that's what your axle is slid into and we had to slide it out of. I'll set that over here. Alright, now these are your spider gears. Now, some people do this a bunch of different ways. The way I'm going to do it is there's some roll pins here that you can see, maybe not, and you got to drive those out so that your cross shafts like this and the cross shaft to hold these together comes out. And what I'm going to do is I am going to weld in between the cogs on these so that they can't spin and turn. I don't know how it's actually going to work out. Like I said, I'm going to get a new differential soon here, so I'm not really worried about messing it up. This is all an experiment, and we shall see how that. Okay, so I got done welding them. My camera died, so I kind of had to skip a few steps with that. So I weld these up, and they've cooled off. So let you guys look at what I did here, and I'll show you what I did. Okay, my workbench is a wreck. But anyways, we're at some point in here. So, if you take this off, those are your spider gears in there. And I welded. I very carefully took a marker and marked which cogs needed to have, you know, a tooth in it. And if they didn't have a tooth in it, I welded it and marked it. So, you can see there. And that's the pattern was straight across on both of them. It worked out pretty well. And then, let's pull this. So on these, I welded the cogs opposite of each other, and that pattern of the weld is all for the same for all of them. And so that's how that works. So before, you know, this gear here could spin, and now it can't because I welded. Now, welding these was a little tricky. It's hard surfaced, so I got all the oil off them, and I went in with a grinder, and I took off the hard surface and then welded in there. I cranked my welder up to like 21, or what the hell we do here? Okay, so that is what I used to weld it. Seemed to work pretty well. I don't know if you're using a MIG, give you an idea where to be. But yeah, it worked out really well. There was a little bit of splatter, and I made sure that when I used my ground clamp, I did not put the ground clamp on this surface underneath this washer here, so that it wouldn't arc and create a spot where this couldn't, you know, sit nice and flat. And there was a little bit of splatter in the teeth that are fitting down in the gear, but I was able to go in there with a small file or emery cloth and clean it out. So that is pretty much that. That is how it's welded. There's play and slop. I don't know if I like that. I knew that was going to happen, but that seems like it's going to, you know, things can move and they can jar and hit harder. That's not good. But I plan on getting a spool, so if it wrecks it, I'm getting a spool anyways. And the reason I did this, instead of just welding the spider gears to the entire carrier, was if it doesn't work, I can just buy new spider gears and put it all together again, and I take it apart easy. So that was my reasoning behind that. So now it's just wash, rinse, repeat, and I'll put it back together. So I got the carrier set back in here. I already did one side of the spanner nut, and I'll show you how to do it on the other side. So there's a spanner nut on either side of the carrier that pushes the races and the bearings fore and aft, and that's so you can adjust your backlash on the ring and pinion. So the spanner nut, I just set it down in the threads on the case side. You want them good and clean, and you turn it, make sure it's lined up on the threads, not cross-threaded. And then you take I'll take the cap, and I'll set the cap down, and we can't cross-thread the threads in the cap, the bottom, and we need our bolt holes to line up here, because you can set it off to the sides and not have your bolt holes lined up. So you need your bolt holes lined up. We'll see if it works first time. Sometimes it takes a little bit. Okay, so just moving freely. Let's make sure our bolt holes are lined up. Okay, our bolt holes are lined up. So I'll just take a little smack on the top. Make sure it's good and set. And this should still, the spanner nut should still spin nice and good and free. So I'll bring those back down, and I put just a touch of preload on them, just snug them. You know, just a couple hits with an impact. Okay, so I got this set up. It's not a great setup. Hopefully you can see this, but I got zeroed, and my backlash is about 50 thousandths. So what that means is we need to move the ring gear into the pinion. So we need to move it that way. So I'm going to loosen this spanner nut up, and I'm going to go about one hole over. So I'm going to back it out one hole, and I'll tighten the other one by one hole. Finally got set right. If I move it back, we have about 10 thousandths of backlash. And in general, I think they say 8 to 15 thousandths is what you want. That's kind of on the tight side. I might loosen it out a little bit, but we're really close. So at this point, we can go ahead, we can tighten up our caps, and we can start going back together with it.